So one of the skills you'll be responsible to know is determining if two figures are similar. The answer is yes or no. And technically there's not enough information to show that these are similar, but we'll just assume that there is. So when I look at this, I see that 2 times 2 is 4, 6 times 2 is 12. So I would say that these are, yes, similar. Because to get from 2 to 4, you multiply it by 2. And to get from 6 to 12, you multiply it by 2. So because it's the same scale factor, I would say yes, they are similar. Here, going from the small number to the small number, from 1 to 5, you'd multiply by 5. And if you look at the other one, 2 to 10, that is also times 5. And technically, 2 sides does not show that they're similar, but for what you're doing on the exam, you'll say yes. Since they're both times 5, you'll say yes, similar. Here, going from 1 to 3, that'd be times 3. But when you go from 2 to 5, that's actually 2.5. So since those aren't the same number, I'll say no, not similar. Here, going from 5 to 25 is times 5. And then going from 2 to 10 is times 5. Same scale factor, so I would say yes, similar. Next one, determine if the triangles are similar. So another way you could see if something's similar is set up a proportion. So 10 to 25, so I'll put 10 over 25. Does that equal, and then it would be the small side with the small side, so the 4 is going to go with the 10. Does that equal 4 over 10? And then does that equal 8 over 15? 6 over 15. And then if I punch those in my calculator, 10 divided by 25, that's 0.4. 4 divided by 10 is 0.4. 6 divided by 15 is also 0.4. So because all the sides are proportional, and they're all equal to 0.4, by the SSS for similarity, we would say yes, similar. Yeah, you could go ahead and try yourself. You could try the next set of triangles over here and see what you get. So here, are they similar? We have 6 divided by 3. Does that equal 12 divided by 4? Six divided by 3 is 2. 12 divided by 4 is 3. Those are not the same number, so I'm going to say no, not similar. Okay. Here's another example. So this is called the SSS similarity postulate. If the measures of the sides of a triangle are proportional to the measures of the corresponding sides, then the triangles are similar. So that's exactly what we just did. We set up the proportion, and on this triangle they're all equal 0.5, so we could say that the triangles are similar. See that? Another theorem says if two triangles are similar, then the measure of their corresponding perimeters are also proportional to the measures of the corresponding sides. So not only are the sides proportional, but so are the perimeters, and we're going to use that in the next problem. So they tell us, they draw us two triangles, and they tell us right here that the two triangles are similar, and they want us to find the value of each variable. I see an x, I see a y, I see a z. And they also tell me that the perimeter of RST, the perimeter down here is 9. That comes from here. So what that means is we can set up a proportion, because I know what the perimeter of this is. 6 plus 3 is 9, plus 4.5, 13.5. So this perimeter is 13.5. So then I can use that because the perimeters are also proportional to the sides. And so what I could do is I could go, if I want to find x first, I would say x over 3 is equal to, I went that way, so I'm going to go this way, 9 over 13.5. From there I'm going to cross multiply. I get 13.5x is equal to 3 times 9. Then I'm going to take 27 divided by 13.5, and I get 2. So I just found that this side is 2. So now we know x is 2. That leaves 7 left over between y and z, because this whole thing needs to add up to 9. And so now we're going to set up another proportion. You can use the perimeters again if you want, or you can use 2 and 3, your choice. I might use 2 and 3 because those are easy. So I'm going to say 2 to 3. So 2 to 3, and then let's find z first. So z to 4.5. Cross multiply. 4.5 times 2 is 9. 3 times z is 3z. Divide both sides by 3. Z is equal to 3. So if z is equal to 3, you could set up another proportion. You could do 2 to 3 is y to 6, or you could just know that the perimeter is 9. So 2 plus 3 is 5. That leaves 4 left over. This should be 4. So then I would say x is 2, y is 4, z is 3. Alright, number 5. Find the missing angle measures in the triangles. Well, we can use the triangle angle sum theorem. We know that these three angles add up to 180. So I'm going to take 180 minus 85 minus 53, and that equals 42. So I'll say angle B is 42 degrees. And then these three angles add up to 180. So I'm going to take 180 minus 47 minus 64. That leaves 69. So this is 69 degrees. So I'll say angle F is 69 degrees. And then these three angles add up to 180. So 180 minus 69 minus 47, 64. So I'd say the measure, you could say the measure of angle H is 64 degrees. Probably better to put that M there for measure. And then finally, these three angles add up to 180. 180 minus 85 minus 42, 53. So the measure of angle K is 53 degrees. So in order for these triangles to be similar, the angles must be the same. So are any of these triangles similar? I have an 85 here, no 85, no 85, 85. I have 85, 85, 42, 42, 53, 53. By the AAA theorem for similarity, these triangles are similar. So I would say triangle A, we'll call this ABC, is similar to triangle, as we just said that this triangle and this triangle are similar. So if I start at 85 degrees, I need to start at 85 degrees here, so I need to put J first. And then I went to B, which is 42, so I need to go to L next. J, L, and then K. So those are similar. Also, 64, 64, 69, 69, 47, 47. Those are also similar, these two triangles. And so I'd say triangle EF, we'll call it DEF, is similar. And I started at 64 degrees, so I'm going to go 64, and then I went to 47, so it'll be 64, so it'll be HGI. And I forgot my triangle symbol, hold on. Alright, what must be the value of x? So I'm going to do number 5, and I'll let you do number 6 yourself. What must be the value of x in order for the figures to be similar? So I'm going to set up a proportion that we're going to do x. So that's the short side, so I must go with 8. So x to 8. So that should equal 57 to 24. I cross multiply 24x and then 8 times 57, 456. Divide 456 by 24 and I get 19. So x must be 19. Alright, so these triangles are similar. Find UV. We know these two triangles are similar. We have a value 5 times x plus 11. That does make this trickier. Notice they're wanting us to find the value of uv. So I'm going to have to find x first and then plug it in to find uv. And so I'm going to set up a proportion. And I see that uv goes with SR. I know that because they're both in the first two positions. So I know that uv goes with SR. I guess I could have just looked at the graph or the picture and it looks like that. So I'm going to say 5x plus 11 over 18. And that's going to equal 88 over 24. I cross multiply. (24) and it's 24 times 5x and times 11, so I need to put that in parentheses. And then 18 times 88. Go ahead and type that in my calculator. That's 1584. I then distribute the 24 to the 5x. 24 times 5 is 120. I distribute the 24 to the 11. 24 times 11 is 264. I then subtract off 264 from both sides. (1584) divided by, or minus 264 is 1320. Take 1320 divided by 120, and I get 11. So x is 11. And if they ask you for the value of x, you'd say the answer is 11. But the answer is not 11. They want you to find uv. Uv is 5 times x plus 11. So what is 5 times 11? Uv is 5x plus 11. But you know that x is 11. So what's 55 plus 11? That'd be 66. So uv is 66. Alright, on this problem, we did this in the practice where we took DE and then we scaled it down using this as the center to get DE, the image DE. And I just want you guys to notice this here at the bottom, that if you dilate a segment that doesn't go through the center of dilation, then it always produces a parallel segment. So if your center, so here's my original segment DE. If the center was anywhere on DE, then the new segment would also be on DE, so then they're not parallel. But if your center is not on DE, it'll always make a parallel segment. So remember, when you're trying to find the scale factor, if you take what you start with, the length divided by what you ended up with, that forms a ratio. And if that scale factor is bigger than 1, the figure becomes larger. And if that scale factor is between 0 and 1, not including 0, not including 1, the figure becomes smaller. So which of the following describes the image of a figure after a dilation of a scale factor between 0 and 1? they're dilating between 0 and 1. Example A, it has a different shape. Nope, when you dilate, it keeps the same shape. Can't be that. It has the same shape, it has the same shape, it has the same shape. Good. It has the same shape as the original. D says it has the same shape and is the same size. That would be congruent. Now I'm down to B or C. Now, does it get larger or smaller? If it's between 0 and 1, the figure becomes smaller. So I'm going to choose C. Now what about if you dilate with a scale factor of 6? Its sides are 6 units longer. Its sides are 1/6 as long. Its sides are 6 times as long. Or its sides are 6 units shorter. This would be a subtraction. This would be addition. 1/6 would make it smaller. 6 is supposed to get bigger, so I would choose 6. So if you have a dilation with a scale factor of 6, it makes it 6 times as long. We didn't talk about this, so I just want to make sure we cover it real fast. Now, if the scale factor of a dilation is negative, we have done no dilations with a negative scale factor. The pre-image is also rotated by 180 degrees, and so if the scale factor is bigger than 0, a dilation with a scale factor of negative k is equivalent to the composition of a dilation with a scale factor of k that is rotated 180 degrees about the origin. So if I ask you about negative scale factors, like -2, you would say -2 still makes it larger. It's just also going to be rotated. -3 would make it larger. -4 would make it larger. -5 would make it larger. So if it helps, just drop the negative sign and just know that it's rotated also. And then any number that's negative between 0 and 1, like -0.2, will make it smaller. -0.3 will make it smaller. -0.4 will make it smaller. So just recognize the negative numbers also make it larger and smaller, but it also does the rotation, which we didn't cover. In the diagram below, we have quadrilateral A, B, C, D that's dilated from the origin. What's the scale factor? So anytime it's at the origin, I would encourage you to write down the coordinates. Like for B, B is 2, 1. The image of B is 4, 2. So how did I get from 2, 1 to 4, 2? And this is where I started the pre-image. Well, I just multiplied them both by 2. So I would say the scale factor is. Circle all the true statements regarding the similar figures below. So they tell me that these are similar. And the first thing they say is that A, B, C, D, so A, B, C, D is similar to G, H, E, F. So A goes to G, B goes to H, C goes to E, D goes to F. That looks true to me. And then another way you could say it is that F, E, H, G. So you're starting with the small part first, but then over here you're starting with the large part, A, B, C, D. You would want, if you're going to call this F, E, H, G, then you want to call this D, C, B, A. So this one will not work. Angle A and angle G are corresponding. They're congruent. So does A go with G? Does A go with G? Yes. Those should be congruent. They're in the same spot. What about BCDA? let's see, B, C, D, A. So then I should name this H, E, F, G, which is what they did. And if I take AB over GH, so AB over GH, does that equal CD over EF? Yep. And then if I take BA over HD, so BA over HD, so going this way, does that equal FE over DC? So I'm going this way, and then I'm going that way. That won't work, so that's no. And then which of the following is true? There exists a series of rigid motions that takes ABCD on the GHEF. Rigid motions would be not what we're looking for, but there exists a series of similarity transformations that will take this onto this. So what you're looking for is similarity transformations, not rigid. Alright, let's say we have to know that these lines are parallel, otherwise we can't do anything. So let's say these are parallel. Then that means the triangles are similar. And so sometimes it helps to draw two different triangles. So like we have the small triangle. So the small triangle right here, ADB, if I could write ADB, and then I put the measurements, that's 11 and 6 right here. Now it should be similar to the whole triangle. So the whole triangle would be ACE. So AC would be 6 plus X. And then this whole thing would be 16. So then I could set up my proportion that's 6 over 6 plus X. So 6 over 6 plus X goes 11 to 16. And then I cross multiply 11 times 6 plus X. Eleven times 6 plus X equals 6 times 16. 6 times 16, 96. Then you distribute the 11. That'd be 66 plus 11x. And then you're going to subtract off 66 from both sides. And you get 11x equal to 30. Take 30 divided by 11. I'm going to get 2.73 approximately. Okay, a person is standing, so he's right here. A person is standing 40 feet away from a street light. This is a street light. The street light's 30 feet tall. So how tall is this person if the shadow is 10 feet long? Luckily they gave us a picture. And so if you're standing straight up and down, that's going to be parallel to a light pole, because light poles go straight up and down. They should. So because these are parallel, we know that the small triangle is similar to the larger triangle. So I might draw myself two pictures here. Little triangle, that's 10 by x. Bigger triangle, that would be 10 plus 40, 50, over 30. And I can look at this and tell the answer because 10 times 5 is 50. So I'm going to take 30 divided by 5 and I get x is 6. So I can do that in my head. But I'm going to go ahead and set up the proportion that 10 over 50 is equal to 10 over 50, x over 30. Cross multiply, 50x, 30 times 10 is 300. Divide that by 50, you get 6. So the person is 6 foot tall. So he's a short. Okay, you may also see a review problem. It's not going to be a proof, so I'm not going to do a proof with you. But you have to remember the different theorems that show congruency. So some of them are SSS, SAS, ASA, and then I know there's other ones, I can't think of them right now. But if I'm looking at this, and we'll just talk about it, we're not going to do the proof. AC and DF bisect. So AC and DF bisect each other. So AC and DF bisect each other. That means they cut each other in half. So this equals this, because E cuts it in half. And then this equals that. And we know that these angles are vertical. So now I have S, angle S, S, angle S. So I know these two triangles are congruent by SAS. So we're not going to do the full proof, but I know that these are going to be similar by SAS. And then finally, if you have two angles, it's called the angle addition postulate, that these two angles should equal the whole thing. So ZHG, this part's 11x minus 1. And then IHG is 24. But then the whole thing, IHG is 12x plus 13. So I know this plus this is this. So I'm going to set up my equation. And then solve. Negative 1 plus 24 is 23. And then I'll subtract 11x from both sides. Subtract 13 from both sides. 23 minus 13 is 10. That'd be 1. So x is 10. They didn't ask me to find x. They said find the measure of IHG. IHG, here's my formula. So I would need to take 12 times 10, 120, plus 13, be 133. So the measure of angle IHG is 133.